everyone is born with a perfect smile. And while some are happy to live, at last change is in the wind. And ironically, it's here just outside Vienne in central France, where dentistry is undergoing its next revolution. It's finally putting its money where its mouth is, and has come up with a process that designs and fits a dental crown in just 40 minutes.
Ok. Bon, alors maintenant on va regarder un petit peu tout ça.
This is Dr. Francois Duret. Over 15 years ago, he imagined a computer that could design and automatically manufacture crowns. The result of his insight is at last being put into practice. It's a CADCAM system, that's computer-assisted design and computer-assisted manufacture. It allows Dr. Duret to design, manufacture and fit a crown in his own surgery in just one sitting. It's one thing to design an object from scratch on the screen and then manufacture it, but it's quite another to design something as individual as a tooth to fit inside a person's mouth. So this camera or probe was developed to take a series of photographs inside the patient's mouth. That photograph is translated into digital data, which in turn is transferred to a computer that constructs that data into a 3D image on the screen. It's not enough for Dr. Duret to examine the tooth in isolation. This camera allows him to see the nearby teeth in both the upper and lower jaws, so he can make sure the new crown won't interfere with the patient's bite. The computer analyzes the data and produces an image on the screen of a crown to fit this tooth. The dentist can also modify this to fit in with surrounding teeth and to match up chips and the like, so both sides of the mouth are the same. Once the design is decided, automation takes over. This is the other revolutionary stage of the process. Traditionally, crowns have been made by pouring hot liquid, usually gold or platinum, into a mould. But in this process, the false tooth is actually carved, and that's given Dr. Duret the opportunity to develop a brand new material that's stronger and therefore longer lasting. It's the white bit here, and it's called a riste, and it's carved using the CAM half of the process, which is computer-assisted manufacture. A riste is a mixture of a commonly used dental material called composite, refined glass fibre and ceramics, a combination that gives it a very strong internal structure. It's strapped into the micro-milling machine, a digitally controlled device that carves the material at very high speed. The machine selects its own tools and carves first the top of the crown, then the underside. And here it is, the almost finished tooth. All it needs now is a little refining around the edges and some hand colouring so that it resembles the surrounding teeth. That's not bad for just 30 minutes.
Close your tooth. Okay, it's finished now. Please, you can see.
How does that feel?
It's very nice.
That didn't take very long.
No, it was a short time.
And you won't have to come back again.
No, I think I won't need to come back here.
Crowns are just the beginning. Dr. Duret hopes that within 10 years, complete sets of dentures will be made using the CAD-CAM technique. The equipment is transportable and therefore adaptable to existing dental surgeries. After 15 years of hard work, Dr. Duret is confident his crowning glory will revolutionise dentistry. Crowns, bridges and dentures will be cheaper, faster to produce and fitted in an instant.
It's very important, of course, and I think with CAD-CAM you can obtain a good smile in a very short time.
New teeth while you wait. That's quite a concept. That's all from this edition of Beyond 2000.
Welcome to Diadem Digital Solutions, home of Diadem Precision Technology. Diadem will help you elevate your laboratory with precision industrial milling that your dentists will notice, experience, and truly appreciate the difference. At the Diadem Learning Center, we can assist you with the tools and knowledge to connect your lab seamlessly to our technologies. Whether your lab receives data files from an impression device, scans an impression, or scans a model, Diadem will team up with your staff to help you become an expert in digital design. Digital design will enable your lab and technicians in ways you never thought possible. Your Scan and Design Center is the key to our multi-million-dollar facility. Sending Diadem a virtual case could not be easier. Simply go to our online portal and upload the CAD file in just a few simple steps. Once your restoration design is uploaded, our technical support team will review the file and prepare your digital design for the precision milling process. And our world-class customer service is always on hand to walk you through every step of the Diadem experience. Positioning of the digital design is critical and is a key component to achieving maximum strength and aesthetics for the desired final result. With our rotors technology, including RC3 automation, Diadem will help you differentiate your laboratory with precision industrial milling. Using an integrated coding system, each digital design is logged and ready for precision milling. The coded mounts are loaded onto the automation rack. The robotic arm takes the mount and transfers it into one of the industrial milling chambers. With precision accuracy, the rotor system proceeds to efficiently mill the ceramic material. When complete, the robotic arm removes the mount and delivers the final milled restoration to a Diadem technician. The technician rescans the mount, which is now ready for finishing and quality control. The mandrel is removed, and the restoration is thoroughly examined. The Diadem team is committed and passionate about quality. The milled restoration is now ready for shipping, and it is verified against the original order. The restoration is packed, and the laboratory will receive delivery in less than 48 hours. Your lab applies the art. And with minimal post-finishing necessary, your bottom line is sure to improve. Our technology will amaze you, and our lean manufacturing process will help you keep your business profitable. Diadem, your technology partner, providing you with automated digital restorations on time in your lab when you need them, delivering the most precise fit in the industry. Experience Diadem Precision Technology.
Thank you, GB, for that passionate introduction to our new T-Series. Many of you may be familiar with me by now, especially if you are an active Facebook user. I'm Mate CTO, Mike Lee. So, the basic concept behind the T710 is simplicity. Simplicity in design and simplicity in workflow. Our focus, as always, has been to ease the work of our users, and we are doing just that with the T710. Let me briefly explain the technology behind the T710. All you need to know is that we have 4 camera systems, each camera having 5 megapixel resolution. A light source emits light patterns vertically and horizontally on the object, which camera capture. By capturing both vertical and horizontal light pattern, the 4 camera system ensures that there is no blind spot in the scan data. The 5 megapixel resolution of the camera also ensures that you get more detailed images. you will be able to see that your scan data is more vivid and lifelike. And did I already mention that you can scan a full arch in just 8 seconds? Yes, 8 seconds. That's even faster than waiting for your laptop to boot up. But we don't compromise on accuracy despite the speed. Our T-Series scanner adheres to strict international standards for accuracy. At 4 micron accuracy, you can be assured that your scan data is not only high in quality, but also accuracy. And as we mentioned,
software allows you to switch the scan sequence to suit your workflow. And the best thing is, the software will remember your scan sequence for future job. So you can scan always in the scan sequence you prefer.
Let's begin scanning now. First, let us show you what our scanner can do in 8 seconds. I'll just put this top model of the mandible into the scanner here. You can see that the T710 is adjusting the scanning height, introducing our new auto elevation function. Now you no longer need to stack up half jigs to find the correct scanning height for your stall models. We will now proceed with the base scan, 8 seconds. Let's begin the countdown.
Eight seconds. I was wowed the first time I saw this scanner in action.
Incredible. Okay, so we will now proceed with the die scanning.
We have an additional function for users who also own our i500 intraoral scanner. You can see here that there is an i500 icon. If you click on this, you can add a scan using i500. Hyojun will show you how it works.
That's basically it. We'll now move on to the maxilla scan stage. With our 4-camera system, you can actually get the full scan data of a stall model without die scanning. We'll now show you how that works now. Here we have an unsectioned model of the maxilla. You will see that the 4-camera system captures both the vertical and horizontal light patterns to produce a complete nude image with no blind spots.
Check out the level of detail. Here on the software, the images are so vivid. More importantly, the 4-camera system ensures that there are no blind spots. So you can capture all the important in the proximal area as you can see the screen.
Also, I personally like the design of our new T-series because of the wide scan area that makes it so easy to put objects in. Even the huge articulators like the one I'm holding, you can put it comfortably in an upright position just like I did. And that's it. You can let the T710 do the rest. There's no need to change the position of the articulator for multiple angles because the scanner swivels the articulator comfortably to take the necessary shots.
As you can see the software, the T710 takes just 3 shots for the occlusion. One-step scanning to get the occlusion data. Now, let me show you a really cool function in our software, auto alignment. Align your FREP data with the base data, or align the base data with the occlusion data. The software does that work for you. Just like that.
So we have shown you how well our T710 scans stall models. Let us now take a look at how it scans impressions.
There are 2 scan strategies for impression scanning. You can either scan only impression or scan both impression and die. We will show you the second option.
The beauty of our 4-camera system is that it scans impressions really well. You can see it for yourself.
So we will scan the impression. Instead of scanning the die, let's do something different. I will now import the data of the die we scanned previously. This is one of the many benefits of an open system. You can always import all the scan data working on new projects. Now, all we needed to do is to align the data for the impression and the die. That's done.
So let's just recap what we went through today. You've seen how our 4-camera system scans multiple objects perfectly with no blind spots. You've seen our cool auto elevation function.
We will show you the auto alignment function and the nifty scan switching sequence function, or Meta scan for labs.
And who can forget how quickly the T710 scans the full arch?
That's right, just 8 seconds. With the T710, you can experience a quicker and simpler workflow. Although the software is packed with many features, you don't need to think too much about it.
Right. All you need to do is put your models into the scanner and let the software do the rest.
And that concludes our demo. Thank you for watching.
Very good. Such a great demo.
Really good, great.
How did you like the demo? I hope you enjoyed it as much as I did.
Our R&D team really worked hard on bringing you this quality product. And we are excited for you to start working on your project with it.
It was a pleasure being able to introduce our new T710 scanner today. I hope that you'll be able to check this out for yourself soon.
We are also looking forward to receiving your reviews about our new T-series.
Great, isn't it? It is truly an exciting time to be with Medit, and I hope that you could see
This video tutorial from Exocad will show you some of the new features from Exocad's latest release, Plovdiv version 2.4. The Plovdiv release includes more than 64 new features, as well as 45 enhancements to existing functionalities, with the main focus on advanced removable design. In the denture module, the software provides new manufacturing methods for all denture situations. Milled or printed production methods may be used for denture bases and denture teeth. For production of the monoblock try-ins, you can now easily export and save a monolithic try-in denture during the design workflow in the wizard. Note, monoblock can only be created for open and semi-closed libraries. Bridge connectors between denture teeth are enabled to facilitate post-processing. The software will now open at the last wizard step of the tooth placement. As you can see here, below the attachment. To add, remove or smooth material, use the Exocad known freeforming tab. Subtract. Let's look at the extension and the space with a nice finishing line for the acrylic in the cut view. Let's compare the offset. In Plovdiv, The gingiva design shape can be influenced using several parameters. You can change the thickness of the base, the cervical border thickness around the teeth,
Good afternoon and welcome to our Making Meal web.
And an ported at the end of the with this interface, this protection cover will be automatically assigned. The screw channel on the upper side of the object, you must do it with a T-tool. Okay, complete the connection. Okay, I usually tend to do it quite fast. Okay. Okay. So the first step is to identify the emergence profile by clicking here.
Good afternoon.
Creating a new is sustaining. So if I select completed our supporting, we jump to the next step. Next step is basically the slicing. So here we have all our software database once we import the file. Can be, of course, different gas depending on if the machine is dedicated to titanium or to other metals, not flammable metals. And here you set basically the direction of the gas flow. And depending on this gas flow, we make sure that the scanning direction of the vectors of the laser path will never be at the same direction of the gas flow.
Welcome to the T-Scan training video. This is of their first bicuspid in place so that the sensor, as the patient pin contacts, the sensor status in to take another, choose a type of scan that alternatively the
to your code and press OK. The probes on the patient by clicking the plus button and the impact. In this performing the chewing test, reading the chewing report results, reading the report.
Under Implant Tool, to press OK for the change. For intraoral is verified, click OK.
Conventional piece of movement related to patient's bones, accurate crown and tooth notes. With the registration technology we have developed for years in our surgical guide solution, the alignment between CBCT data and are generated automatically, and the brackets are placed from the video. Most of the work is done by the system. When the software is running in a clean check-like style, one can not only move the teeth, but also visualize the IPR values. The IPR value limits can be set so that the teeth will show red when the IPR values.
So each of these shows. This works by clicking anywhere in the circle to bodily move the segment. Clicking on the square will allow you to move the pivot point, the measurements on, or make a note that that will need to be adjusted at the time of surgery. There's an automatic uncross button here that will take everything out of crossing if you choose to use that as well. Also available in the treatment
click on the first one. Order overview tooth select. Creation tooth material requirements. Always check how it may affect your design.
Begin
when
with
your design is ready, you can
in
check
the surveying and blocking out step. Have to play beneath. Menu in the stip file format. In this video, you'll if the middle the animation tool and the server from the. We do recommend watching other videos suggested in the description box.
Optimal insertion direction to gingiva. Keep occlusal view when using this button and move the mouse cursor within the window between geometrical shapes to define margin line outline. Then, use the Snap Gingiva option to check abutment design to make final adjustments to design.
In this video, obtain crown occlusal plane. gingiva level. When active, select settings finished. Finalize step. All-in-one implant. Analyze via model set into format or spacing. The software enables you to inspect the changes in the occlusion using the colored occlusion map tool. And finally, you're able to create a printable report for documentation. All your analysis and measurements will automatically be listed in this report. We hope you found this video inspiring. To know more details about Ortho Analyzer tools and workflows, go and watch our how-to video.
Digital plane can then be fine-tuned. It allows the user to visualize and control these settings. Opposing arch, and then so how does automated points once you exported the setups for manufacturing,
now customizable. You can activate just or a simple click will toggle to a more intuitive 3D view. Cavities, but manufactured in multi-layer material.
View it from an area, especially in the back, molar region. Remember, longer supports are less stable and could break while printing if they are too thin. Thick support should. You can add supports to the vertical. Depending on click view. Now you can close the project.
For dental implant surgery. Tracking throughout the surgery. The procedure starts with a CT scan of the patient. The surgeon plans the surgery, accounting for key anatomical features like the nerve, sinus, and adjacent teeth. Yomi achieves physical guidance through the use of haptic robotic technology. It physically constrains the surgeon's drill movement to match the plan.
Hello and welcome. This is a Formlabs dental video. My name is Sam Wainwright. I'm the dental product manager here at Formlabs, and I'm here with our resident dental technician and expert, Bill Slocum.
Thank you, Sam. Today we'll be speaking about the Formlabs Digital Denture, the latest dental offering for the Form 2 3D printer.
In this video, we're going to go over three main topics. We're going to give an introduction to the 3D printed denture and what it consists of. Second, we're going to go through briefly some CAD considerations on digital teeth libraries and cards. And third and finally, we're going to go step by step through the manual denture solutions and state of each resin if you are looking at the application guide. We've been mainly using software output, but there are also and try the dental CAD software. In this section, we're going to go through the workflow and how to post-process and finish a 3D printed denture from the Form 2. We will be picking up right after the parts have been removed from the build plate and washed. We will be starting with removing the supports from the denture base and the denture teeth. To remove the supports, Bill's using his dental handpiece and a cutting disc to cut the supports and smooth them away. After the supports are removed, you'll notice that our teeth are splinted together, and we've found for the best aesthetic results, reduction of the interproximal connection will help make a more natural look. Combining the 3D printed base and teeth is easy. Once you remove the supports and washed your parts, take a small cup of denture base resin and wet the sockets with a brush. Place the teeth into the sockets starting from the posterior. Press the base and teeth together with one hand, and with the other hand, use a handheld UV cure light to tack the parts together. Continue repeating this process and move across the arch and forward until complete. You can also add denture-based resin to the interproximals or remove excess resin if needed. To finalize the connection of the teeth and base, the denture should be cured in a form cure. The denture should be placed into a 4-cup Pyrex container filled with glycerin and submerged. For 30 minutes, the denture should be cured in a form cure. Then flipped over for an additional 30 minutes of curing, for 60 total minutes. During this final cure, the two parts become one. Once the denture is fully cured, simply polish it the same way you would a traditional denture. Using a rag wheel with pumice at low speeds will help it smooth the prints without flattening or removing characterization. Finally, using an acrylic high shine at high speeds yields a truly impressive result. Yeah, the process to combine the base and the teeth through luting is actually pretty easy.
It's definitely much easier than setting teeth by hand in wax and processing in the traditional manner.
We're very excited to see what everybody's thoughts and opinions are on this 3D printed product. If you start 3D printing dentures on your Form 2, send us some pictures. Our email is dental@formlabs.com. We'd love to see what everybody's doing. I bet people are going to do some pretty incredible stuff with this technology. This has been a Formlabs Dental video. We really hope you enjoyed it and it's been helpful. My name is Sam Winwright. This is Bill Slocum.
Your Datron machine M100 process builds dental depending on the Z height and the exposed area. When the process is unpacked, the platform is removed of the EOS building platform, which was created using additive manufacturing, into the insertion of the hybrid front-loading door of the integrated 8-slot automated blank changer. Automatic loading of the hybrid fixture from the magazine into the clamping device of the Datron D5 using a pick-and-place system. Precise measurement of the 0 point of the building platform using 3 measuring pins created during the additive manufacturing process with the help of a tactile 3D infrared touch probe. High precision post-milling of individual abutments, cavities from secondary constructions, crowns, bridges, and one cam to minimize 70% less machine.
Measure it. This is Dr. Drill the depth over the. When we reach green, which is the field depth, indicating we've gone a little too far. Thank you very much.
Good job.
3.
3.
Pause.
5.
Next one, please. Thank you. We should not have to measure these from here on out. We're just sequentially going up in size. Reamer, 3.
3. And then we're going to
Guide.
guided. Good job. Good job.
3.
3.
Guide. Introduce any material. And then I use